All right, welcome back, everyone. In this segment, we're going to be talking about what is robotics from the perspective of trying to differentiate between automation and robotics. That really is what we're looking at, differentiate between automation and robotics, and define in a simple way robotics. There's going to be a deeper definition at some point, but I want to concentrate ourselves on those two items as we have this conversation here. So robotics versus automation, sometimes they can be used interchangeably, or sometimes they can be confused, but there are some slight differences when we talk about industrial automation versus robotics. Automation is not exactly equal to robotics. That's one thing that we can differentiate. Automate is to control machines using advanced technologies typically involving electronic systems. And you're going to get to where I'm getting at here in a little bit. So that's the definition. Automate is to control, condition, or automatic operation with little human intervention or interaction. As another definition, there are actually at least two types of automation, and the two types we refer to are flexible and rigid automation. Those are two types of automation that exist today. Maybe they are even talking about a hybrid system today. Flexible manufacturing automations is something that allows you to manufacture more than one product. That is flexible automation. Whereas rigid automation is used in manufacturing, but only to build or manufacture a single product, typically, right? So those are the two basic differences in automation: flexible automation versus rigid automation, right? Kind of important to know. So that leads us to a basic definition. Again, we're going to look into a more technically amplified definition, but for our purposes, robotics is the study and research of the use of robots as a science, right? That's robotics. Robot can be defined as a reprogrammable manipulator, right? That's one simple statement about robots. Robots are used where decisions must be made independently and the activity requires some adjustment in the operation. Those are some of the characteristics of the robotic science. We already provided you a definition for rigid versus flexible automation, but we're going to give you some examples here. So a computer numerical control lathe machine or a computer numerical control milling machine, those are examples of rigid automation, right? And an example of flexible automation will be considered a robot in a manufacturing cell where there is even controls via a programmable logic controller. Those could be part of the classification or category of flexible automations. We've introduced a couple of concepts here: hard automation versus flexible automation. And we have defined the robotics as kind of a science study field, which is basically is a robot, and a robot can be simply defined as a reprogrammable manipulator. That's what we have been talking about in this case. Here are some examples of rigid automation examples. Milling computer numerical control machines, some of you might be familiar with this, and lathe computer numerical control machines. Those are popular production systems today in industry and in academia and in research laboratories. The use of milling, lathe, or combined systems that are computer numerical control, and you can reprogram that. Typically, you can only do a certain piece at a time, right? That's the nature of that. Whereas flexible automation, we can involve in that the use of robots. As a matter of fact, there is some evolution robots where now you have robots in teams, robots that can coordinate tasks among themselves. You also have controllers. We call them PLCs, programmable logic controllers, that are part of the flexible automation. And then you have manufacturing cell where you can integrate all of these. That may include robots, PLCs, and CNC equipment in a flexible automation cell, which will have two types of systems: rigid and flexible systems within a cell. So in review, let's look at a review. Automate is to control machines with the use of advanced technology. What do you say to that? That is true. All right. Automate involves the use of electronic systems. What do you think? Yeah, typically it does. Right. The condition or automatic operation uses little human intervention. I think that's also true. There are two types of flexible and rigid automation that we refer to. That's also true. Flexible manufacturing automation allows more than one product. I believe so. A robot is a reprogrammable manipulator. That's a hard word, right? So it means you can reprogram it. I think it's true. Automation and robotics are exactly the same thing. Well, not from our point of view of definition, right? Automation and robotics are not exactly the same, but they can work together. There's a slight difference between one and the other. Okay, so this is what we've covered so far. I think we've covered all the bases, and we're probably gonna have to stop here at some point because we have gone over the material that we have for this section, where we have started to define a little bit of the automation versus robotics and what within the automation and what's the basic simple definition of robotics. We're gonna get back into this topic with deeper understanding, in other words, amplify, more technically qualified definition for robotics. All right, I hope this is making some sense to you. If not, you can always reach back to me or your peers. You can always post discussions also for everybody to respond. But for now, I just want to thank you for your time, and I'll be seeing you on my next lesson here in a little bit. Thank you. Okay, let us do a more technical definition of robot. And in this segment, actually, which is part of the previous one, we're going to just clearly define what robots are and what robots are not in a more amplified format. So this is what I call technical definition of robotic. Okay, so technically defining robotic, we're going to define what they are, what it is, and what is not, because sometimes you need to have a feel for what something is so that you know what is not. And so that's what I'm talking about here. Let us technically define what is a robot then for our purpose. So what is a robot? By definition, here are some pretty elaborate definitions. A robot is an automatic general purpose machine, right? General purpose machine. It should be machine, sorry about that, or device, right, whose primary function is, and the initial stages of editing this material is to produce movement to accomplish a task. That is a definition. I'm sorry, I'm not giving you the... Okay, so a robot is an automatic general purpose machine whose primary purpose is to produce movement to accomplish a task. That's a pretty good general definition, right? You can buy that. All right, let's see what else we got. Another definition for a robot. This is actually an ample one too, but you can say that a robot is a mechatronic system that combines electricity, electronics, mechanics, computer, and fluid power, and that combined in a system is capable of performing prescribed functions. That's another ample definition, right? It's a mechatronic system that is made out of all these disciplines, and when those disciplines are combined into a practical machine, that machine is capable of performing prescribed functions, right? That's another definition, kind of a deeper level definition. Here's another one, and this is actually the definition that is adopted by the Robotics Industry Association in the US and Canada. And the way they define this is a robot is a reprogrammable manipulator designed to move material parts, tools, or other special devices through movements to complete a task, right? So that actually, it's a pretty nicely technical elaborate definition. No, not too far away from the previous one we've described, but this is actually what the Robotics Industry Association uses to define what a robot is. So we have defined, and they're all identical, right? We have defined what a robot is, right? And in the next part, we're gonna look at what a robot is not. So if a robot is that which we have defined, what is it not a robot? Well, sometimes people think that a robot is a machine that extends the ability of an operator and which has independent capacity. And not quite, right? It's not exactly a machine that extends the ability of an operator. And it doesn't have independent capacity unless you tell it to do something, right? The machine will do it. Another prescription of what a robot is not is a machine that automatically performs a function and it cannot be reset. No, the machine needs to be programmed and told what to do, and it can be reset. That's the reason why we have an operator or technicians or someone around the system, because it's not a fully automatically gonna perform something it doesn't know how to do. We have accomplishments and advancements in automation and robotics, I understand that, and we're looking at what they call autonomous robot, which is really more in the line of smart machine learning and that kind of stuff, but we're not there yet. There's just an early stage of that. Okay, sometimes we also think that the special shuttle arm is a robot, but it's not. That's a teleoperated. We also think that remotely controlled vehicles are robots, but they are not. They're exactly that. They're remotely controlled vehicle, or they are teleoperated devices. Okay, so these are examples that sometimes we can confuse thinking these are robots. Sometimes we refer to these things as mobile robots. And again, there's some fine line definitions that we're talking about here. I hope this is not confusing for you, but we're trying to separate what really a robot is versus what something that may look like a robot, but it's not. Okay, so that's what we have been talking about today. So a robot is what kind of system that combines all these technologies? Well, it's a mechatronic system. That's really a kind of a coiny word that is prevalent today more and more. According to the Robotics Industry Association, a robot is what? A reprogrammable, right? Or program manipulator that is desired or designed to move materials or to perform similar functions, right? What about this statement? Are all robots completely autonomous? No, they are not. They are not. Is a special teleoperated vehicle a robot? Considered a robot? No, that's actually a teleoperator, right? Are remotely controlled devices always robots? No, they're not. They're exactly remotely controlled or operated devices. And so I hope this clears the air, kind of a deep definition about robots and looking into what robots are and what robots are not. So we have two definitions and we have a separation between a true robot and a teleoperated or remotely controlled device. All right, we have gotten pretty deep into this. This is a kind of a nice, deeper technical definition of what we did before. I hope this is making all sense to you. If not, you can always post questions, send me an email, and hopefully we'll try to respond to you. This course is a fantastic course. It's a real deal course. It's what's being used in the industry today. So thank you for your time. See you in a little bit.